Good morning to everyone. Today I am going to take topic on immunodiffusion. So what is immunodiffusion? It is a diagnostic technique. So immunodiffusion is nothing but it is a technique which is used to determine or identify antigen or antibody in a solution or in an analyte. So immunodiffusion is nothing but it's a technique usually used to determine or we can identify the presence or concentration of an antigen or antibody in a solution. So why it is called as immunodiffusion? Here the antigen or antibody diffuse each other to form precipitation. So when the antigen react with the antibody, it will form the precipitation. From the precipitation, we can identify the presence of an antigen or an antibody. So how it will diffuse? It will diffuse in a gel medium. So usually here we use either agar or agarose as a medium where the antigen and antibody diffuse each other, interact, and it forms the precipitation. So this is for the main principle behind the immunodiffusion. So immunodiffusion is a technique where the antigen or antibody interaction takes place in a gel medium where we can see the result as a precipitation. So what is precipitation? When we talk about precipitation, the results will be shown as a precipitation. We have to know what is precipitation, how the precipitation takes place. So before that, the immunodiffusion takes place in two ways. One, both the antigen or antibody in a solution, either one of the antigen or antibody diffuse, another will be kept as a standard gel. So in another way, both the antigen or antibody move towards each other and react, it will form the precipitation. Either of these two ways, the precipitation will take place. In a solution, we will keep one thing as a constant, the antibody as a constant, we will add antigen, the antigen alone move towards the antibody, react with the antibody, will form the precipitation. Otherwise, in a medium, both the antigen and antibody will move towards each other and form the precipitation. Let me see what is precipitation, how the precipitation reaction takes place in the immunodiffusion. So precipitation is nothing but when antigen and antibody react each other, when antigen and antibody react each other, it will form insoluble reactant. When the two reactants react each other and it forms insoluble reactants, that is nothing but a precipitate. So when the antigen and antibody, it will react and it will be in the insoluble form as a precipitate. So this is the principle behind precipitation. And also how the interaction takes place, this antigen and antibody form a lattice formation. So this antigen and antibody will react each other, which will form a complex as a lattice. So that is a principle behind the precipitation. This precipitation will take place only when the antigen and the antibody is in an optimal concentration. So when we take a solution, if it contains an antigen, when we add an antibody, this antigen and antibody will form will form a complex which is lattice formation. This will shows the precipitation. Only takes place when this antigen and antibody is in an optimal equal concentration. What happens if there is not in an optimal concentration? In that case, so when we talk about when we add the antigen, when we add in the antigen in increasing concentration, when we talk about a reaction, both this antigen and antibody react each other and it will form the zone. The place of both the antigen and antibody react each other form an immune complex. That zone we will call it as a zone of equivalence. So this is the point where this antigen and antibody concentration is in optimal condition. It react each other, it will form the zone of equivalence. So where the place when the antibody is excess, when compared to the antigen is not an optimal concentration, when there is an excess antibody in compared to the antigen to react, that zone we call it as a prozone. Prozone is the zone where there is a presence of excess antibody when compared with the antigen to react to form a lattice formation, to form a complex. This is a zone, we call it as a post zone. So here there is a presence of excess antigen when compared with the antibody. So in our solution there is an excess concentration of antigen when compared with the antibody. It will compete for the site. If there is a presence of excess antigen when compared with the antibody to form a complex, that zone we call it as a pozone. When there is only an optimal concentration of an antigen and antibody, there is a formation of zone of equivalence. So this is the basic principle behind the immunodiffusion. When we talk about the types of immunodiffusion, there is two types of immunodiffusion. One, single diffusion. Another one type is double immunodiffusion. Based upon the immunodiffusion principle, the antigen-antibody reaction will take place in two ways. One is single diffusion, another one is a double immunodiffusion. In single diffusion, there is single diffusion in one dimension. Another one method is single diffusion in two dimensions. In the same way, double diffusion, which takes place in one dimension, one direction. Double diffusion in two dimension, direction or dimension. So both the single immunodiffusion and double immunodiffusion takes place in one dimension and also in a two dimension. Let's see single diffusion in one direction. This method we call it as audit method. So how this will be performed is, so in a test tube we will add a agar which is infused with antibody. To this we will add an antigen solution. When we keep it for incubation, so what happens? Only the antigen alone move through the antibody gel to this test solution. This antigen alone diffuse in the gel medium. There it reacts with the antibody. In a place it will form a precipitate ring. Only here one direction, the antigen alone diffuse towards the gel, react with the antibody. It will form the ring of precipitation. It will form the precipitate ring. This method we call it as a single diffusion in one direction. Also we call it as a audit method. So next, single diffusion in two directions. So what will happen? Single diffusion in two directions. Single diffusion in two directions or two dimensions. So this this method we call it as single radial immunodiffusion, also we call it as a Mancini method. Also we can call it as a single radial immunodiffusion, SRID. So what happens in this method? In a plate, we will add a gel which is infused with the antibody. In this we will create a well. In a well we will add antigen solution of different concentration. So what will happen? This antigen will diffuse in the medium, through where it will react with the antibody. It will form the precipitin ring, which form the precipitin ring, or otherwise it will form precipitin ring. All the way react with the antibody, which is already diffused in the agar medium. So in this, what will happen? This antigen and antibody both will move towards each other. It will form the precipitin line. So this method we call it as a single diffusion in two directions. Also we call it as a single radial immunodiffusion. So let me talk about double immunodiffusion in one direction. That method we call it as a variation of Howden method. So double immunodiffusion in one direction. So this method also we call it as a variation of Howden method. So what will happen in this method? In the test tube, we will add antibody infused agar medium. To the medium, we will add plain agar. We doesn't add any of the antigen or antibody in this agar, to which we will add our antigen solution. So what will happen? This antigen will diffuse towards the plain agar and it will react with the antibody and it will form the precipitin line. So this method we call it as a double immunodiffusion in one direction. Also we call it as a variation of Howden method. So what about the next method? Double immunodiffusion in two directions. Also we can call this method as a Aucher-Lamy double immunodiffusion. So in this method, the antigen and the antibody move towards each other. In two dimensions it will move. So this method is an example for double immunodiffusion in two directions. So what will happen in this method? So in the plate, we will add an agar medium. In that, we will create a well. So in one well, we will add antibody. In another two, we will add different antigens. So what will happen? This antigen move towards the antibody and antibody will move towards the antigen. It will form result in the different formation. So why we using this method is usually to compare the site of an antigen and also to find the identity between the two antigen to the antibody. We will go for an alternative double immunodiffusion. So here we can interpret the result in three forms. One is identity, non-identity and partial identity. So what is identity? When both this antigen share the site at the antibody, which is common for this antibody, the result we can interpret as an identity. When both the antigen will not share any of the common epitope in the antibody, which is completely different for this antibody, we can interpret the result as non-identity, through which the result can be shown as a crossing lines. When both the antigen partially shares the site, which is not completely common for the antibody, there we can see the result as a partial interpretation. In that you can see the semi-curve with the lengthened arc. Okay, so this is what interpretation from the immunodiffusion. Let us sum up what is immunodiffusion. Immunodiffusion is nothing but which is a technique usually used to identify the concentration of an antigen or presence of an antigen along with the antibody. In this immunodiffusion, we will perform the experiment in an agar medium. In this, either both the antigen or antibody move towards each other in an antigel, or otherwise any one of the antigen or antibody move towards each other, form a precipitate line. Here the result we can interpret in a precipitation. So in this two methods, single diffusion and double immunodiffusion. In single immunodiffusion, we can have two types. One is in one dimension, another one is in a two dimension. The same way, double immunodiffusion, we have one dimension and two dimension. This method, in one dimension, either one antigen or antibody will move, another will kept constant in the gel. In a two dimension, both the antigen and antibody in the gel move towards each other, will form the precipitate line. The same way, double immunodiffusion, either antigen or antibody, any one move in the gel, form a precipitate line. The same way, two dimension, double immunodiffusion, both the antigen and antibody move towards each other, react to form a precipitate line. Thank you.